Find the limit of the sequence whose terms are given by a sub n equals n squared times 1 minus cosine of 3.3 over n. So we need to find the limit of this. Notice that as n approaches infinity, n squared goes to infinity, and then cosine 3.3 over n, well, 3.3 over n goes to 0, cosine of 0 is 1, 1 minus 1 is 0. So we have infinity times 0, which is an indeterminate form. And whenever you have infinity times 0, you want to either put infinity as 1 over infinity, or the 0 as 1 over 0. So in this case, it's easier to put the n squared on the bottom. So that's what we're going to do. So you have 1 minus cosine of 3.3 over n divided by 1 over n squared. And so what I'm saying is that n squared is 1 over n squared. It's like the reciprocal of the reciprocal. It cancels out. You get the original. Okay, so now on the top we said that goes to 0, and then 1 over n squared also goes to 0, so we can use L'Hopital's rule. So we'll take the derivative of the top and the derivative of the bottom. So the derivative of the top becomes negative 3.3 sine of 3.3 over n divided by n squared. And then the bottom is negative 2 over n squared. Sorry, n cubed. So I can simplify this further. Basically, the negatives cancel, turns into positive. The n cubed comes on top, and the 2 goes on the bottom. So we have 3.3 over 2 times n cubed sine 3.3 over n divided by n squared. Now, the cubed cancels with the square. The 3.3 over 2 comes outside. That's 1.65 times the limit as n approaches infinity. N times sine of 3.3 over n. If we let n approach infinity, we have infinity times 0 again. So we're going to divide by 1 over n. So it's sine of 3.3 over n divided by 1 over n. Now sine goes to 0, 1 over n also goes to 0. So we can use L'Hopital's rule once again. So now we have 1.65 limit as n approaches infinity. We're going to take the derivative of sine 3.3 over n, and that's going to be negative 3.3 cosine 3.3 over n divided by n squared. The derivative of 1 over n is negative 1 over n squared. The two negatives become positive, n squares go away. This 3.3 is going to come outside and multiply the 1.65, and you get 5.445, and then limit as n approaches infinity of cosine 3.3 over n. Now as n approaches infinity, 3.3 over n goes to 0. Cosine of 0 is 1, so we're just left with 5.445 as our limit.